Welcome to the AmericanAVK Series 66 Gate Valve Overview Module. In this module, you'll get an overview of the Series 66 gate valve, including function, history, construction features, product range, standards compliance and testing, and installation. So, what exactly are gate valves, and what are they used for? Gate valves are one of the most common valves used in water distribution systems and are suitable for both above-ground and underground installations. These valves are typically used for on-off service and are installed in pipelines as isolating valves. Gate valves are often used when minimum pressure loss and a full bore is needed. When fully open, a typical gate valve has no obstruction in the flow path, resulting in a very low pressure loss. This design also makes it possible to use a pipe cleaning pig. The gate valve stem has to turn multiple times to go from the open to the closed position. This slow operation prevents water hammer effects that can be caused by a quick closing valve. However, if you need a valve to open fast or close quickly in emergency conditions, or to control flow, a gate valve is not the best choice. HDPE, or high-density polyethylene, is currently the dominant material used in water, gas, and sewage lines in Europe. In North America, HDPE is heavily used in gas, wastewater, and industrial applications. It's gaining popularity for potable water lines as well. The polyethylene pipe-to-valve joint was originally developed and patented by British Gas for their PE gas distribution pipe system. It was licensed by AVK International for water, gas, and sewage valves. These valves are marketed in Europe as the AVK Series 36 and Series 38 gate valves and fit metric-sized PE pipe. The design was modified for the North American-sized PE pipes and is known in North America as the AVK Series 66 gate valve. The AVK Series 66 gate valve uses the same high-quality design and valve components as our Series 45 and Series 65 gate valves, with the added benefit of PE pipe connections. If PE pipe is specified in your installation, the AVK Series 66 gate valve with HDPE fusible ends is a perfect choice. And because you don't want bolted joints in your PE pipe system, PE ends for AVK fire hydrants are also available. Boltless pipe assembly means corrosion-free and leak-free joints for a long-lasting pipe system. Now let's discuss the construction features and materials of the Series 66 gate valve. First, let's talk about HDPE. Why is HDPE gaining popularity, and what are its key advantages over iron pipe? PE pipe can absorb 2 times its maximum operating pressure if a surge event such as water hammer occurs. Due to the flexibility of PE pipe, the water hammer energy is absorbed quickly and does not cause damage to the more rigid components of the pipe system. Ductile iron and PVC pipe, on the other hand, are very rigid and will therefore transmit the water hammer energy a great distance through the pipe until the energy finds a weak spot in the pipe system and may rupture the pipeline. This flexibility also allows the PE pipe to bend and flex without rupture when exposed to seismic events, freeze-thaw, and soil constriction. It's so flexible it can be bent around cul-de-sacs. The flexibility of PE pipe also makes it relatively softer than PVC or iron pipe. It's therefore more susceptible to cuts and gouges in the material. However, according to PPI guidelines, the PE material can withstand a gouge that is up to 10% of its total wall thickness without impacting the pressure class. PE pipe has a very smooth plastic inner surface when compared to the rough surfaces found inside iron pipe. This means that water flows through PE pipe with much less resistance, lowering pumping cost. PE pipe ends can be fused together to form a self-restrained, leak-free pipe system. These fused joints are as strong as or stronger than the pipe surrounding the joint. And PE pipe systems will last well over 100 years with no pitting, cracking, corroding, or any of the other typical failure problems of iron pipe systems. In fact, PE pipe has the lowest failure rate in the market. The Series 66 valve bodies, bonnets, gland flange, and wrench nut are made from ductile iron according to the ASTM A536 standard. The wedge is ductile iron encapsulated in EPDM rubber. EPDM stands for ethylene propylene diene monomer. The AVK EPDM rubber compound is approved according to the NSF 61 standard for contact with drinking water and does not impart any rubber taste or odor to the water. The AVK EPDM is a synthetic rubber compound that is resistant to sunlight, ozone, chlorine, chloramine, rubber set, tearing, and cuts. The optional coating on the Series 66 wedge is NBR. NBR stands for nitrile butadiene rubber. It's sometimes referred to as Buna-N or simply as nitrile. NBR is not NSF 61 approved for long-term contact with drinking water and will impart a rubber taste into the water. The AVK NBR rubber compound is resistant to mild acids, petroleum-based oils, greases, and other organic compounds sometimes found in wastewater. It's also resistant to rubber set, tearing, and cuts. However, it is not resistant to long-term exposure to sunlight or ozone. The wedge nut and thrust collar are bronze. The bronze wedge nut is locked into a pocket located at the top of the ductile iron core of the wedge. The surrounding ductile iron does not allow for deformation of the bronze under heavy compression loads, such as over-torquing the valve in the closed direction. This allows the AVK gate valve to withstand much higher closing torques than are required by AWWA C515. For example, a 6-inch AVK gate valve equipped with the standard stainless steel stem can withstand a closing torque over 1,800 foot-pounds and still be operable, where the AWWA standard only requires that it survive a closing torque of 350 foot-pounds. The standard bolting material for all AVK gate valve bonnets is 304 stainless steel. As an option, 316 stainless steel bolting is also available. The bonnet bolts have a hexagon-shaped socket head that require an Allen wrench to install and remove. The bonnet bolts are threaded into a tapped hole that has been drilled into the top sealing surface of the valve body. They are not secured with nut fasteners through an open flange, but are threaded directly into the valve body. The head of each bonnet bolt is sunk into a recess that is cast into the top outer edge of the bonnet. After the bolts have been installed and tightened, a hot melt glue is applied over each bolt head to further protect the head of the bonnet bolt from corrosion and soil. This design completely isolates the bonnet bolts from any contact with water from inside or outside the valve. If, many years from now, the valve is disassembled, the bonnet bolts would still look brand new. The bonnet gasket, wiper ring, O-ring stem seals, and O-ring gland seal are NBR to ASTM D2000. The bonnet gasket on all AVK gate valves is an O-ring type gasket that wraps around each bonnet bolt. This design not only provides an excellent high-pressure seal against leaks, but also protects each bonnet bolt from the corrosive effects of water from inside or outside the valve. The position of the gasket is maintained under pressure by the bonnet bolts and a groove that is cast into the underside of the bonnet sealing surface. The standard synthetic rubber material for the bonnet gasket is NBR to resist permeation from organic compounds in the surrounding soil. However, as an option, an EPDM gasket is also available for special applications. The NBR and EPDM gaskets are resistant to rubber set. In other words, after use, the gasket will return to its original shape and thickness. The standard stem is made of 430F stainless steel for potable water applications, but a low zinc bronze stem is available as an option. The standard 430F grade stainless steel stem threads are rolled, not cut, to ensure smooth thread edges for smooth valve operation, and a work-hardened surface to resist wear. The 430F material is highly resistant to corrosion in applications where it is exposed to potable water, and complies with the ASTM A582 standard for stainless steel stems. The optional low zinc bronze stem has a high yield strength and is recommended for applications where the valve may be exposed to unknown chemicals in wastewater or exposed to salt water.